Good morning all. Welcome back to next lecture. Today we will discuss the important application of linear equation in economics. See, in economics, equations are extensively used to model various relationships and behavior within the economic system. And this equation can help the economist understand, analyze how different factors interact and influence the outcome in the areas such as its production, consumption, investment, pricing and market equilibrium. One of the most common type of equation which is used in economics is demand and supply equation. And see, these equations actually express the relationship between quantity of goods and services supplied by producer and the quantity of demanded by consumers, and both are it's typically the function of price. The demand is inversely the function of price and the supply is positively the function of price. And the equilibrium in the market occur where the supply is equal to the demand, leading to the determination of market price and quantities. And these are actually it's crucial for business policy makers and economists, especially to understand this relationship, as it helps in making informed decision regarding the price, production level, resource allocation and market interventions. So here actually we are going to consider the demand and supply analysis involving one commodity model, two commodity model and three commodity model as an application of the system of linear equations. See, demand actually refers to the quantity of product or services that the consumer are actually willing and able to purchase at various price level during a specific period of time. We can say that a demand equation which also expresses the relationship between price and quantity, and it is showing typically that is quantity demanded of a commodity which is the function of price. So it is a function that actually describe how the quantity demanded changes as the price is going to change. So in general, the demand curve is a downward sloping curve, indicating that the price of commodity decreases, the quantity demanded is increases and vice versa. See, similar way, we know the supply as well. We are defined many times. Once again, I am repeating here. The supply refers to the quantity of a product or service that producers are willing and able to offer for the sale at various price level during a specific period of time. So the supply, we have a supply equation as well, and which represent the relationship between the quantity, how much quantity of commodity is supplied by the producer and its price level. And it can be generally expressed as QS is equal to function of price or function of P, where quantity supplied is equal to function of price. So it is a function that actually describes how the quantity supplied changes in response to the changing in the price of commodity. And in equilibrium, what we can say, the market equilibrium can occur where the quantity demanded is equal to the quantity supplied, which leads to the market clearing prices or market determined the prices and quantities. So mathematically, the equilibrium is represented by the point of intersection where the quantity demanded is equal to quantity supplied. QD is equal to QS, which means quantity demanded is equal to quantity supplied, and this equilibrium condition actually determine the equilibrium price and the equilibrium quantity in the market. Now, let us consider a simple linear function that is quantity demanded is equal to A minus BP. And here the negative sign before B, which indicates that this is a demand curve which is slope downward, implying that there exists a inverse relationship between the price and quantity demanded. And linear supply function is also given here. See, QS is equal to C plus dP, which express the relationship between quantity supplied of a commodity and its price in a linear form. So here what actually showing the curve is upward sloping, because here it is showing a positive sign for the coefficient of P, so which showing that the supply curve is slope upward, implying that there exists a direct and positive relationship between price and quantity supplied. So accordingly, we are going to find the equilibrium point here. In equilibrium, we know the quantity demanded is equal to quantity supplied. So here quantity demand is equal to A minus BP, quantity supplied is equal to C plus dP. We are going to equate these both terms. So it will become, see, quantity demanded, instead of quantity demanded, we are writing here A minus BP, which is equal to quantity supplied, which is C plus dP. Now we are going to take the P term into the, or variable term into the right hand side of the equation and constant term into the left hand side of the equation. See, C will become, see, it's become minus C, and minus BP will become plus BP. So here P is common, so we are taking P into the outside. So we can write it is, D plus B into P, where P is common, A minus C is the constant. Now here we are going to isolate P. Then P is equal to, it is dividing both sides of the equation by D plus B. Then it will become A minus C divided by D plus B. And this is what actually showing the equilibrium price, or it is the market price which is prevailing. Okay. Now after finding the P is equal to A minus C divided by D plus B, we are going to substitute this particular expression into the demand equation or the supply equation. See, if you go for substituting the P is equal to A minus C divided by D plus B in the demand equation, then it will become, see, this is the demand equation, that is A minus BP. Then substituting, instead of P, we are putting it is A minus C divided by D plus B. So if you go for taking the common denominator by including A, and multiplying and dividing the A term by using D plus B, then it will become, see, A into D plus B minus B into the numerator term, that is A minus C whole divided by D plus B after taking the least square denominator, LCD. Now, see, we are going to multiply this particular version, especially by opening the bracket. So it will become A into D plus A into B minus B into A minus B into A minus B into minus C. So it will become plus BC whole divided by D plus B. So here AB and BA is cancelled out. Here it is plus sign, here it is minus sign. So these two terms will be cancelled out, and what is remaining? It is AD plus BC term divided by the denominator, see, D plus B. So this is representing the market equilibrium quantity. Okay. Now find the equilibrium price and quantity from the given equation. See, the quantity demanded is given here. Quantity demand is equal to 100 minus 2P. Then quantity supply is equal to 20 plus 3P. Now we are going to find out the equilibrium level. See, in equilibrium, we have quantity demanded is equal to quantity supplied. So we are putting, instead of QD, we are putting here 100 minus 2P. Then instead of QS, we are putting 20 plus 3P. So it will become 100 minus 2P, which is equal to 20 plus 3P. Now we are taking the P into the one side of the equation and constant term in the another side. See, taking minus 2P into the right hand side, so we are going to add the plus 2P in the both side of the equation. So it will become 3P plus 2P. Then here taking the 20 into the left hand side of the equation, so it will become minus 20. So if you go for solving it, then 100 minus 20, which is 80, 3p plus 2p, which is equal to 5p. Then dividing the both side of the equation by using 5, then we can say that it is 80 divided by 5, which is equal to 16. So this p actually showing that it is the equilibrium price which is prevailing in the market. Now, once P is received, then you can substitute the value of P in any one of the equation, either in the demand equation or in the supply equation. So, if you go for substituting here, then it will become, see, substituting in the demand or supply function. See, we are considering here it is demand function. So, demand function is equal to 100 minus 2P. So, 100 minus 2 into 16, P is equal to 16. So, if you go for solving it, then 100 minus 2 into 16, which is 32. So, it is 100 minus 32, which is equal to 68. So, quantity demanded is equal to 68, which is also equal to the quantity supplied, and the market price is the 16. So, in this way, we can find the equilibrium price and quantity from the given quantity, demand and supply function. Now, consider the another example. See, the demand and supply function are given. We want to find out the equilibrium price and quantity in the similar way what we are explained in the earlier as well. See, quantity supplied is equal to minus 20 plus 3p and quantity demanded is equal to 220 minus 5p. So here we are going to make equal to each other. So quantity supplied is equal to quantity demanded. Quantity supplied is minus 20 plus 3p, which is equal to quantity demanded, which is 220 minus 5p. So we are taking the p term into the or variable term into the one side of the equation. It will become, see, 3p, taking minus p into left hand side of the equation, it will become plus 5p, which is equal to 220 plus minus 20, it will become plus 20 here. So it is 8p, which is 240, dividing the both side of the equation by using 8, then it is 240 divided by 8, which is equal to 30. So 30 is the equilibrium price level. Then after finding the equilibrium price level, you can directly go for the substituting this particular value in the demand or supply function. So here in the supply function, we are going to substitute. So here the supply function is minus 20 plus 3p. So p is here 30. So it will become minus 20 plus 3 into 30. So it will become 90, minus 20 plus 90, which is equal to 70. So quantity demanded is equal to 70, which is also equal to the quantity supply as well. Now we will have the another equation. See, the demand and supply function of a commodities are given here. That is P is equal to minus 2QD plus 50. Here P is equal to 1 by 2 QS plus 25. And we want to determine the equilibrium price and quantity. So see here, it is possible to calculate these values using algebra, and in equilibrium, you know, quantity demanded is equal to quantity supply. If this common value is denoted, see here, in the equilibrium, quantity demanded is equal to quantity supply. Therefore, what we are assuming, this QD is equal to QS, which is also equal to Q. So we are going to substitute Q term for both QD and QS. So accordingly, this will become, see, P is equal to minus, instead of QD, I am substituting it is Q, because QD we are assuming which is also equal to the QS, which we are denoting in terms of Q. So minus 2Q plus 50, and second equation will become P is equal to 1 by 2, instead of QS I am writing it is Q plus 25. So now this represents a pair of simultaneous equation for the two unknown P and Q. You know, so we could be solved using the elimination method describing, you know, the previous lecture as well. However, this is not strictly necessary because it follows an immediate from the above equation. So we can directly solve it by substituting quantity demanded is equal to quantity supply. So here we can equate each other because we have only one variable we are considering here, it is quantity. So here minus 2Q plus 50, which is equal to 1 by 2 Q plus 25. Now taking the Q term into the one side, see, I am taking 1 by 2 Q into the left hand side of the equation. So it will become minus 1 by 2 Q plus 50 which is equal to 25. Taking 50 into the right hand side of the equation, so it will become minus 50. Then minus 2 minus 1 by 2, so it will become minus 2.5. So it is minus 2.5, q is equal to minus 25. So q is equal to, dividing the both side of the equation by using minus 2 by q, which is equal to 25. So q is equal to 25 here. Then, sorry, q is equal to 25. Here it is, we are substituted, it is p, but it is q is equal to 10. Then we are going to substitute in the demand function. So here we are already said that quantity demanded is equal to quantity supplied, which we are denoting in terms of q. So instead of qd, I am substituting the value of q is equal to 10. Here it is wrongly written, that is p is equal to 10. It is q is equal to 10. We are going to find out p here. So p is equal to minus 2 into, instead of qd I am putting it is 10 plus 50. So if you go for solving it, then you will get p is equal to 30. P is equal to, price is equal to 30. And if you go for substituting in the supply function, then also you will get the same result. So here you can check it by substituting q is equal to 10 here also. See, 1 by 2 qs, instead of qs we are going to substitute the 10. So it will become 1 by 2 into 10 plus 25. So here 1 by 2 into 10 which is equal to 5 plus 25 which is equal to 30. So here also we 30, here also we have 30. So quantity demanded which is equal to quantity supplied which is equal to 30, and at the same time the price is equal to 10. Now see, here we are going to consider another example. The equilibrium condition for two market, that is butter and margarine, is given, where PB, butter, we are denoting the PB for the butter and PM is the margarine, and the price of butter and price of margarine is given here respectively. So here 8 PB minus 3 PM which is equal to 7 minus PB plus 7 PM is equal to 19. So here the price that will bring equilibrium model, see, we can find either by using the substitution method or elimination method, because we have a simultaneous equation with the two unknown variables, that is PB and PM. For example, here we are going to consider a substitution method. Then first we can solve one equation for the another variable in terms of, see here, solving equation number 2, that is here for PB. Then we can go for directly substituting here. So the equation number 2 here, minus PB plus 7 PM which is equal to 19. So I am solving this equation for PB. So it will become 7 PM minus 19. Now I am going to substitute PB on the equation number 1. So it will be 8 PB minus 3 PM which is equal to 7. So I am going to substitute here the PB is equal to, see, 7 PM minus 19. So 8 into, instead of PB, it is 7 PM minus 19 minus what is remaining here? It is 3 PM which is equal to 7. So 8 into 7 PM which is 56 PM minus 8 into 19 which is 152 minus 3 PM which is equal to 7. So 56 PM minus 3 PM which is equal to 53 PM minus 52, then plus 7 which is equal to 159. It will become minus here. So it will be 159. So PM, therefore we are going to divide the both side of the equation by using 53. So it will become, see, it is 3. 159 divided by 3 which is equal to 3. So PM, the price of margarine, it is 3. Now substitute PM on the equation number 1 so that you will get the PB also. So here 8 PB minus 3 PM is equal to 7. Substituting PM is equal to 3 on this particular equation, so it will become 8 PB minus 3 into 3 which is equal to 7. So here we can solve it. 8 PB is equal to 9 here, so 9 plus 7 which is equal to 16. So PB is equal to, dividing the both side of the equation by using 8, so 8 divided by 8 and 16 divided by 8 which is equal to 2. So price of butter is equal to, it is 2. Now we can solve the same example by using the elimination method as well. See, we have two simultaneous equations. We are going to eliminate here one variable, either PB or PM. See, we are going to multiply the equation number 1 by 7 so that the first equation will become 7 into Pb minus 3 Pm, which is equal to 7. So it will become 56 Pb minus 21 Pm, which is equal to 49. I am denoting it is third equation. Similarly, I am denoting taking the second equation and multiplying by 3. So you will get, see, this is the original second equation and I am multiplying with 3. So it will become, see, I am multiplying with minus 3. So it will become 3 Pb. Minus 3 into minus Pb, which is equal to 3 Pb minus 3 plus 7, which is equal to 21 Pm, which is equal to minus 3 into 19, which is equal to minus 57. So by taking these two equations, see, we have a 21, minus 21 and minus 21. In order to cancel out minus 21, see, we are going to subtract the equation. So here 56 Pb minus 3, which is equal to 53 Pb, which is equal to 21 minus 21, which will be cancelled out. So 49 minus 57, so it will become plus. So 49 plus 57, which is equal to 106. So we have a 53 Pb, which is equal to 106. So dividing the both side of the equation by using 53, we can isolate the Pb, which is equal to 106 divided by 53, which is equal to 2. Now we can substitute the value of Pb is equal to 2 in equation number, first. So equation number first is here 8 Pb minus 3 Pm, which is equal to 7. Substituting Pb is equal to 2 here, so it will become 8 into 2 minus 3 Pm, which is equal to 7. So 8 into 2, which is equal to 16 minus 3 Pm, which is equal to 7. See, minus 3 Pm, I am taking 16 into the right hand side of the equation, so it will become minus 16. So minus 3 Pm, which is equal to minus 9. Dividing the both side of the equation by using minus 3, Pm will become 3. So the same answer which we are already received in the earlier cases by using the substitution method which is also equivalent to the elimination method as well. Now consider the another example. See, we have the quantity demand and supply function for two interdependent commodities which are given here. See, quantity demanded of commodity 1 and quantity supply of the commodity 1 is given, and similarly the second commodity is also given here, and we want to determine the equilibrium price and quantity for this particular commodity. Now in equilibrium we know the quantity demanded is equal to quantity supplied. So we have quantity demanded 1 which is equal to quantity supplied 1. Similarly quantity demanded 2 which is equal to quantity supplied 2 as well. So here, see, taking the first equation, that is Q1, I am denoting QD1 which is equal to QS1, which I am denoting as Q1. So Q1 is equal to 10 minus 2P1 plus P2. Similarly this term also I am making it is Q1, so it is minus 3 plus 2P1. So now we can equate these two terms. See, hence we can say that 10 minus 2P1 plus P2 which is equal to minus 3 plus 2P1. Then if you go for simplifying it, you will get 10 minus 4P1, that is minus 2P1 which is equal to minus 4P1 plus P2 which is equal to minus 3. So I can again simplify it, minus 4P1 plus P2, taking the constant 10 into the right hand side of the equation. So it will become minus 13. Now considering the second equation, that is QD2 and QS2 is given, we are treating it as a Q2. So Q2 is equal to 5 plus 2P1 minus 2P2, which is equal to minus 2 plus 3P2. So we are equating here, then you will get 5 plus 2P1 minus 2P2, which is equal to minus 2 plus 3P2. Now we are rearranging this particular equation, then you will get 5 plus 2P1 minus 5P2, which is equal to minus 2. So subtracting here 3P2 from the both side of the equation, you will get 2P1 minus 5P2, which is equal to 7. Now we have a simultaneous equation from these two equations. See, 4P1 plus P2 which is equal to 13, 2P1 minus 2P2 which is equal to 17. So now this equation is simultaneous equation with two unknown variables are here. You can use the elimination method by multiplying equation number 2 into 2. So this is the equation number 2. If you multiply this with 2, then it will become minus 4P1. That is, we are writing the first equation here, minus 4p1 plus p2 which is equal to minus 13. Then multiplying the second equation, see it is by 2, then it is 4p1 minus 10p2 which is equal to minus 14. So this, if you go for adding up these two equations, then minus 4p1 will be cancelled out. Then 1p2 minus 10p2 which is equal to minus 9p2 which is minus 13 minus 14 which is equal to minus 27. So here we can divide the both side of the equation by using minus 9, then p2 is equal to 3. When p2 is equal to 3, then we can substitute in the equation number 1, then you will get, equation number 1 is equal to minus 4p1 plus p2 which is equal to minus 13. So here I am substituting p2 is equal to 3, then you can solve it and accordingly you will get p1 is equal to 4. So substitute p1 and p2, substituting p1 and p2 in the quantity of 1, so you will get q1. q1 is equal to 10 minus, which we are already found earlier, 10 minus 2p1 plus p2 which is equal to, see substituting p1 is equal to 4, then q1 you will get it's equal to 5. Similarly, we have q2 function as well which is equal to 5 plus 2p1 minus 2p2. Then you are going to substitute here p1 and p2, then you will get q2 is equal to 7. q2 is equal to 7. Now we are going to consider the last equation, that is find the price and quantity for the three substitute goods, especially which is given here. Three equations are given here and we are going to equate with these three equations. See, first we are considering qd1 and qs1. So it is equal to qd1, qs1. You will get 23 minus 5p1 plus p2 plus p3 which is equal to minus 8 plus 6p1. Then you simplify it, then you will get minus 11p1 plus p2 plus p3 which is equal to minus 31. Similarly, from the second equation you will get, see, by taking these two equations, then you will get 15 plus p1 minus 3p2 plus 2p3 which is equal to minus 11 plus 3p2. You can simplify it, then you will get p1 minus 6p2 plus 2p3 which is equal to 26. Now by taking the third one, again you can equate, you will get p1 plus 2p2 minus 7p3 which is equal to 24. So we have three equations here, equation number 1, 2, 3. Now we have simultaneous equation with the three unknown variable case. So these three equations are written here. First we are going to consider, first 1 and 3, equation number 1 and 3 we are going to consider here by multiplying equation number 1 by 2 so that p2 can be cancelled out. So multiplying equation number 1 by 2, the equation will become 22p1 minus 22p1 plus 2p2 plus 2p3 which is equal to minus 62. Then considering the third equation as well, so we have this equation is written here. Now 2p2 is, we have same coefficient, so we can eliminate here p2 by subtracting the equation. So minus 22 minus p1 which is equal to minus 23p1, these two terms will be cancelled out. Then 2p3 minus 7 plus p3, so it will be 2 plus 7 which is equal to 9p3 which is equal to minus 38. So this is I am denoting here, it is the equation number 4. Similarly, I am going to consider the equation number second and third one, so that I can again remove the p2, then it will become p1 minus 6p2 plus 2p3 which is equal to 26. Then I am multiplying with the third equation, this is third equation by 3. Considering the third equation by 3, multiplying 3, then 3p1 plus 6p2 minus 21p3 which is equal to minus 72. Now here 6p2 we have common. So here, see, we can add it so that we can cancel it out. p1 3p1 which is equal to 4p1, this will be cancelled out. 2p3 minus 21, so it will be minus 19p3 which is equal to minus 98. So we have equation number 4 and equation number 5. We have a simultaneous equation with two unknown variables. Solving this particular two variable case by using elimination method, So I am going to multiply equation number 4 by 19 so that it will become, equation number 4 will become 4 minus 437 P1 plus 171 P3, which is equal to minus 722. Similarly, multiplying the equation number 5 by 9 so that I can make the P3 is the same coefficient. So it will become 4 into 9, which is 36 P1 minus 19 into 9, which is equal to 171 P3, which is equal to minus 882. Now I am considering these two equations. So we can remove here P3 because 171 we have same coefficient. So the sign here it is plus and minus, so we can add it so that we can remove the P3. So minus 437 plus 36, which will become minus 401 P1, which is equal to minus 722 minus 882, which is equal to minus 1604. So P1 is equal to, if you go for simplifying it, P1 is equal to 4. Now substitute P1 is equal to 4 on the equation number 4 or 5. Here we are going to consider the equation number 5. Then it is equal to 4P1 minus 19P3, which is equal to minus 98. So P1 I am going to substitute, it is 4. Then 4 into 4 minus 19P3, which is equal to 98. So you can simplify it. 4 into 4, which is 16 minus 19P3, which is equal to 98. Taking 16 into the right hand side of the equation, so it will become minus 16. So if you go for simplifying it, P3 is equal to, dividing the both side of the equation by minus 19, which is equal to 6. So we have a P1 is equal to 4 and P3 is equal to 6. Then we are substituting the P1 is equal to 4 and P3 is equal to 6 on equation number 1, so that we can find the value of P2 as well. So this is the equation number 1. We are substituting here P1 and P3. So it will become minus 11 into P1, which is equal to 4 plus P2 plus P3, which is equal to 6, which is equal to minus 31. So if you isolating P2, then it will become P2 is equal to minus 31 plus 44 minus 6, and P2 is equal to, if you go for simplifying it, P2 is equal to 7. So we have the P1 which is equal to 4, P2 is equal to 2, 7, P3 is equal to 6. So this is the solution for the simultaneous equation with 3 unknown variable cases where demand and supply functions are given and the price of various commodities are already found here. P1 is equal to 4 and P2 is equal to 7 and P3 is equal to 6. So let me conclude here. Today we have discussed the important application of linear equation in economics, that is demand and supply analysis. We have also solved this is mathematically by using different models of demand and supply by using along with the examples. I hope it is clear to you and we will see in the next lecture. Thank you.